Let's complete the last two examples I have for you in section 7.4. In this one, we have a multi-process. It's a survey asking mobile phone users how long they would wait for a page to load. Found the following results. Find the probabilities that the person would wait the following amounts. And we're going to start with A. The probability that they'd wait more than 10 minutes. So let's look at our table now and figure out what we have. We have less than a minute is 2% of the people would wait for a page to load. 1 to 5 is 17, specifically, because these are all groupings of categories. In other words, they could wait 2 minutes, 3 minutes, and all the way up to 5. Then we have 6 to 10 for 33, which is the largest as we can tell. 11 to 15, 17%, 16 to 20 seconds, 14%, and greater than 20 seconds, is 17%. I said minutes. So they said no more than 10 seconds. So in 10 seconds, no more than 10, that means that this is the amount of what they would wait for. So we would have the 2% plus the 17% plus the 33% are all the people, all the values of percentages that are less than 10%. And we would add them. And let's see if I can get this up over here. That would be 2 plus the 17 plus the 33. And I get 52. So 52% of the people they surveyed said that they would be willing to wait no more than 10 minutes. I forgot the no. Thank you. All right. Okay, now we have the second one. The probability of at least 6 seconds. All right. So in this condition, we have those from 6 to 10, and then we would have the ones 11 to 15, and then we would have 16 to 20 seconds, and of course greater than 20. All of these are at least values in the chart. So we're going to add those percentages. That would be the 33% plus the 17% plus the 14% plus the 17%. And we would add those values up in our calculator. And we would get 81%. Again, learning how to read a chart of percentages that are the probability factors for that table. This one is interesting because it says they want the probability they'd wait between 6 and 20 seconds inclusive. Inclusive means include those values. So as we look at the chart, we're saying we would want the 6 to 10 category. We would want the 11 to 15 category, 6 to 20 inclusive. And then we'd have the 16 and 20. Not any larger because it is inclusive of the 6 to the 20. And that's why we did that. Now we're going to add up all of our percentages. So that would be the 33 plus the 17 plus the 14. So we do that math. We would get 60, it looks like 64, 33, 17, and 14. Yes, 64. Of those surveyed would be willing to wait between those values. Okay, so now we're at the D, and the D one says probability between 1 and 15 seconds. Again, between the two numbers. All right, well, let's consider which of those are. 1 through 15 would be 1 to 5 grouping, 6 to 10 grouping, and 11 to 15 grouping. So at this point, this is 17%, and this is 33%, and this one is 17%. These are pluses. I put a comma, sorry. All right, so let's do the sum of that. 17, 33, and 17. And it looks like 67. Okay, so that would give me 67%. Let me get the calculator down. All right, so we've learned how to read a formula, determine something is in line as a probability table, and now we're doing our very last problem. If the odds that a given candidate will win an election are 8 to 7, what is the probability the candidate will lose? The odds given the candidate will win. So this is win over lose. All right. All right, so what we need first is our total. All right, so if it's those numbers, then we know that it had to have been 8 over the total over 8 over the 7 over the total, so that we would get the 8/7. And if you remember from our rule, because we have taken a break a little bit, we add the two numbers to get the probability, and then work at what we need. Okay, so we know then the probability that the candidate will lose All right, so we already know that 8 out of 15 is win. So we're going to have 1 minus the probability of win. 1 minus, and this is 8/15, so we would have 7/15. All right, because we want the candidate to lose. Is everybody comfortable with that? Okay, well, now we've learned all we needed on the basic concepts of probability, the fact that it can be stated as a percentage, a fraction, a decimal, and the idea that if it's on one set of data, it equals as close to 1 as possible. So thank you so much for listening. Do your homework.